In this video, I will talk about extracting information from textual data. Textual data refers to information stored and presented in written form, like books, scientific articles, news articles, emails, social media updates, and the list goes on. Essentially, any data expressed through words. The volume of textual data has been growing rapidly, and it creates opportunities both for researchers and for companies. For example, customer support can gain valuable insights into customer needs just by analyzing emails or chatbot interactions. Most of these services have chatbots these days, but also another medium is from social media feedback. To handle this efficiently, though, machine learning tools are often employed for processing and analysis. So let's look at first thing, how is textual data collected? There are several methods to gather textual data, and those include surveys, chat transcripts, and social media monitoring. But what would be an example of textual analysis? Textual analysis involves examining written content, like we were talking before, books, articles, websites, and then identifying recurring themes and patterns. There are some advantages to textual data. First of all, it is easily accessible. You can find it pretty much anywhere. You can find books, articles, reports, social media, and so on. Collecting this data and storing it, it is relatively cheap, comparing it with images or even worse, with videos. You can gather a great amount of information from textual data. By analyzing textual data, you can discover patterns and trends, and you can get insights, for instance, into what people feel through sentiment analysis. But obviously, all is not perfect. So there are, of course, also some disadvantages. First of all, textual data is often unstructured. It is susceptible to bias by just the fact that it's human language, so it's subjective by nature. And it can be time consuming in some cases to annotate because manual annotation is needed. And we will see this later on. It can many times contain errors and inaccuracies, and that leads to wrong conclusions a lot of the time. So then, how do we make sense of all of it? The answer is natural language processing, or NLP in short. These days, NLP is all around us, really. It's part of our day-to-day. All of us, most of us probably have used voice-enabled assistants like Siri, Alexa, Google Assistant, and these are only a few of the most popular. All of us have used a chatbot on some website, and some of us even a voice-operated GPS system. All these artifacts use NLP to function properly. But what is NLP? Natural language processing, to repeat it again, or NLP, is a branch of computer science and artificial intelligence which applies machine learning, and through that it helps computers comprehend and interact using human language. So we are not talking now about general artificial intelligence, but about the fact that NLP allows computers and also other computational devices to identify, interpret, and produce both spoken and written language, and it does this by combining various fields like computational linguistics, artificial intelligence, information retrieval, etc. You now might have the inclination to think that NLP is a very new field, but in fact it existed more than 50 years. And if we go deep down in history, certain aspects of NLP are actually even hundreds of years old. Today, NLP is advancing very rapidly, and this is due to computing power and improvements in access to data. This progress allows the experts to achieve impressive outcomes. And we can see those in human resources, in finance, in media, in healthcare, and so on. I won't go into that because it is not the point I want to make today, but you can find a lot of information online if you care about it. Two things I want to introduce here. These are the ones that you see here, natural language understanding and natural language generation. So let's get into it. What we care in the context of NLP is natural language comprehension. And by comprehension, I mean it here in a very broad way. And this comprises two big areas, like I was saying earlier, natural language understanding, NLU, and natural language generation, NLG. In natural language understanding, we aim to map up text into knowledge representation. And we will see just in a couple of slides how. But basically, we aim to understand the user query based on grammar and on the context of the text. And then the inverse of that, natural language generation, or NLG, here we start basically with knowledge representation and map it back to language. So it's the other way around. So basically, we would be generating text from structured data in such a way then that it is back understandable by the user. So NLU basically takes metadata from material and uses it to make computers understand and interpret human language. It aids then in the conversion of natural language input into this kind of appropriate representation. And NLG includes text planning, so locating pertinent information, and sentence planning, so creating pertinent phrases and establishing the tone of a sentence and so on. But now let's look at an example. I was talking earlier about, or I was mentioning sentiment analysis. So let's look into that. This is also known as opinion mining. And it involves examining large amounts of text to assess whether the sentiment conveyed is positive, negative, or neutral. As you can see here, of course, there can be like a larger range than that. Nowadays, companies with more customer data available than ever face both an opportunity but also a challenge in analyzing textual information. But they use textual information to extract valuable insights and make better decisions. So sentiment analysis tools enable companies to gain deeper understanding of their customers, to enhance the customer experience, sometimes to strengthen their brand image and so on. But there are also challenges. Context plays a crucial role in accurately interpreting the emotion conveyed in a piece of text. And often it's a factor that leads to errors in sentiment analysis tools. So no matter how well trained the software is, sometimes it struggles to accurately detect irony and sarcasm. This is because sarcasm or irony is often communicated through vocal tone or facial expressions, and the words themselves don't typically reveal those nuances. Then negation also is an issue because it can occur and then it reverses the meaning of a sentence. And then in English, we also have, as in many other languages, idiomatic expressions. Like, for example, let someone off the hook, which means not hold someone responsible for something. Or then break a leg, which means good luck, funnily enough. But these often confuse sentiment analysis tools and the machine learning algorithms that are behind them. So now that we talked about these challenges, they don't only apply to sentiment analysis actually, but they appear in other use cases as well. But now you might wonder, why would NLP be in general a difficult task? And the first thing that comes to mind is, of course, that all languages are built differently and are used differently. Of course, some languages that are related to each other are more similar than others. Now that we looked at irony, sarcasm, context, negation, in general, the intention of the user might be something we cannot be sure about. But also, the languages are so different and so complex. So let's look at different levels of linguistics, which you can see here in these nested circles. So the first of them is phonetics. This is a branch of linguistics that studies how speech sounds are produced, how they're transmitted, and how they're perceived. So it examines the physical aspects of speech, such as the movements of the lips, tongue, teeth, and so on to create sounds. Then the second one is phonology. Uh, this is the examination of the sound patterns within a language and then also among different languages. So it investigates how speech sounds are categorically organized in the mind and then how they are conveyed meaning. Then we look at morphology. So morphology is the study of the internal structure of words and is a fundamental aspect of today's modern linguistic research. Then the next thing is syntax. Syntax is something probably you're more acquainted with from programming alone, and it is the area of linguistic research that focuses on the arrangement of words in human language. So it examines the rules that are needed to describe a specific language and how the rules can vary between different languages and so on. Semantics is also a branch of linguistics, and this focuses on the study of meaning. It seeks to understand the nature of the meaning as a component of language. So, how it is created, how it is interpreted, how it's negotiated by both speakers and listeners. Now we are at the last level, which is pragmatics. So, think of two common situations. Have you ever asked someone to put the kettle on and then expected them to make you a cup of tea? Or have you ever told someone you are cold, but you intended for them to close the window? This is essentially what pragmatics studies, how context contributes to meaning. This branch of linguistics focuses on language in context and its practical use. And there are some common topics that appear often in pragmatics, like turn taking in conversations, so changing the person who is speaking and the one who's listening, text organization, and then there are two more fancy terms. One is presupposition, and this means that we study assumption in a context. So some information is taken for granted. And then the other fancy term is implicature. And here is the act of meaning or implying one thing but saying something else. So now that we looked at these levels of linguistics, let's look at the NLP processing pipeline. So whatever the application is, um, this is a general representation of an NLP processing pipeline, and it's essentially it's a backbone of building applications which revolved around text analysis. Of course, it can vary from application to application, but it's a good general representation. So we start with text, right? Like we have some kind of a document, but that can be really overwhelming to analyze, right? So what can we do about it? Well, you remember that idea of divide impera, right? So instead of dealing with the text as a whole, we take a first step. We break the text into sentences. So we need to recognize the boundaries of sentences. So that means where does a sentence start? Where does it stop? And this is called sentence segmentation. So the first step. This might sound like a fairly simple thing to do, right? Well, it proves to be not so trivial, actually, if we go about it, and we'll check that out later. If the text is well written, that helps. But a lot of the times it can be very messy and it can become quite difficult. For instance, if you think of transcribed text and so on. So next after segmentation comes tokenization. Uh, we have listed there. The sentence is divided into discrete words or tokens, and this aids in understanding the context. Then, if we want to tell what classes the words belong to, what part of speech they belong to, so that means are they verbs, nouns, pronouns, adjectives, adverbs, prepositions, conjunctions, interjections. There, I gave you a full tour of the 8 parts of speech. So this is called parts of speech tagging or post tagging, and we will see several examples later. So let's not get into the details, the nitty-gritty now, because we will get into it later. Then the next step after we identified which part of speech the word is part of, then comes stemming and lemmatization. So what this does is to reduce the words to their root form. So stemming removes prefixes and suffixes, and then lemmatization maps words to their base or dictionary form, if you will. And this can be very, very helpful. We will talk about the differences between stemming and lemmatization in an example very soon. Then comes stop words, the next step, stop words. Here we eliminate common and less meaningful words. These are called stop words. And those can be in English, for instance, articles like the or a, or conjunctions like and, but, for, to, etc. And these don't contribute usually significantly to the meaning of the text. So we can get rid of them. Not necessarily from the very beginning always, but at some point in the processing. Now, sophisticated algorithms also implement dependency parsing. So we're over here. And dependency parsing represents sentences as trees. So, as the title says, it parses the grammatical structure of sentences, and then it identifies relationships between words, and it determines their dependencies. So this is sort of self-explanatory name. It's not as easy, don't get fooled by it, but the name is quite self-explanatory. Now, many applications perform noun phrases extraction and name entity recognition. Noun phrases are phrases that usually have a noun or pronoun as the head and have the same grammatical function as a noun. And about named entity recognition, we will talk about in a bit. So we will discuss it in more detail later on. These first steps until dependency parsing, so all of these until stop words, but without these parts of speech tagging, we can consider it as pre-processing. And the second part are more sophisticated from dependency parsing on. And this can be performed based on the needs of the use case. It's not always that they are part of the tool that we're building, for instance. But now let's take an example because we've been talking a lot and it would be good to look into something more clear, let's say. So we have this wiki text, right? It says London is the capital and most populous city of England and the United Kingdom. Standing on the River Thames in the southeast of the island of Great Britain, London has been a major settlement for 2 millennia. It was founded by the Romans who named it Londinium. All right. Now, so the first step here is segmentation. It's not, you cannot see it on this page over here because it's quite simple. So we have 3 sentences, right? The first sentence is London is the capital and most populous city of England, and it ends here. The second one, standing on the river of Thames, etc. It ends major settlement for 2 millennia. And then the third one is it was founded by the Romans who named it Londinium, right? This is simple. As a concept, not necessarily to do, but as a concept, it is quite simple. Then we go to the next step. This is tokenization. So I'll remind you what it means. So here, the chosen sentence, the chosen sentence is the first one, right? I forgot to say that. So we are choosing this sentence. London is the capital and most populous city of England and the United Kingdom. So this sentence is divided into tokens, as you can see. So London is one token, is another token, the another token, capital another token, and so on. And now, next step. So the next step in our pipeline was post tagging. So through post tagging, we attach a part of this speech tag to every word. So essentially, London is the proper noun, is the verb, the is a determiner, and so on. Now comes stemming and lemmatization. So I will remind you again, stemming and lemmatization. So through stemming, we reduce the words to their root forms. Stemming removes prefixes and suffixes. And we have here an example. So we have these two words, affluence and affluent. So but by stemming, we discover this common stem. This is why it's called a stem, which is affluent. And then for lemmatization, for instance, we had in this original text in another sentence. If I go back to it, give me a second. Standing on the River Thames in the southeast of the island of Great Britain, London has been a major settlement for 2 millennia, right? Now we go back. So in this example, if we take the word standing, so ending in ing, right? And then stands that ends in s, these are forms of the verb stand. Hence, stand, ending in D, so without ing, without s, is the lemma of these words, right? Okay, so hopefully this is clear. Next comes dependency parsing, which is mainly used to find out how all the words in a sentence are related to each other. And to find the dependency, we can build a tree, as you can see here in this image. And then with this tree, we assign a word as a parent word. So here, the main verb in the sentence acts as the root node. Now, I forgot to mention, what you see here in gray are stop words, right? The words that we were saying that we can get rid of earlier on that are not very significant for the meaning of the text. But here we don't look at the rules of sentence structure. So we look instead of how they are grammatically related to each other. So like I was saying earlier, we are building trees, and these trees labels each word with a single parent word. And then the relations between the words show the grammatical relations between them. What you see here in this figure is called a parse tree. But how do you interpret this, right? So in this case, we see that London, right, has a relation with B, and B, oh, sorry, with is, and then is has a relation with capital. From this knowledge, we can interpret that London is a capital. A machine, though, doesn't know how to parse each word. So in order to do this, the computer needs to be trained to identify each word and generate these relationships that you see here in this tree. So this dependency parsing essentially works by inputting words and sentences through a machine learning algorithm to generate an output result. And Now let's look at, I promised we were going to look at parts of speech tagging. So also called post tagging for short. So post tags contains, if you remember, verbs, adverbs, nouns, adjectives that help indicate the meaning of words and in a grammatical correct way in a sentence. This is what we have to remember. So in post tagging, the computer system tags each token as a verb, noun, adjective, and by recognizing these functions of words, the system can determine the sentence's meaning. However, it's not just a matter of the computer recognizing each word's part of speech. Certain steps must take place first. So each word, along with the surrounding context, is processed through a part of speech classification model. This model has been trained probably on millions of English words and sentences. And to train it, tokens are inputted with their parts of speech already labeled and so on. So it's a little bit of a long process, and it can be sometimes very ambiguous. So let's look a bit at syntactic ambiguity. So taking this example, she saw the man with a telescope. This will be relevant in a minute, you will see. So what can this mean, right? It can be interpreted in two ways, basically. So first is she used a telescope to see a man. This could be one. And another one would be she saw a man who was using a telescope. So which one of them could it be? How can we help with this? And the answer here is post tagging. Let's take another example here on the right. So we were going to look at different post tagging approaches, but first of all, let's look at this example on the right. We have this example, time flies like an arrow. Let's divide it in first two sentences, right? So in the first one, what is the meaning of the first one? So we see that the time is a noun and the flies is a verb. So this would mean that time passes fast as an arrow travels, right? And then we have the second one, time flies like an arrow. This means here, so okay, look at this. Time flies is a noun by itself. It's a noun phrase. And this signifies a creature, as you can see here, right? Time flies. And these time flies, these creatures, like an arrow, said they don't dislike the arrow. On the contrary, they like the arrow, right? And the third one, time flies like an arrow. So this is an imperative sentence. You see that time is a verb here. The flies is a noun. So this is why I was grouping the first two sentences together. Because if you see in the first two sentences, flies is a verb, and then like is a verb. Here, time is a verb, right? So what we're doing here is we're telling someone to time the flies as you would time an arrow, right? So time the flies. This might have been confusing a little bit, but think about it on your own and see how, of course, this doesn't necessarily make any sense, but for machines, they don't really know if it makes sense or not. But now I will give you a fun exercise for you to imagine what could it mean? Fruit flies like a banana, right? So now that we understand what ambiguity can mean, if the word is a noun or a verb, we notice that it can completely change the sentence meaning. So then the tag reveals so much about the word and the surrounding neighbors. It can reveal a lot. But now let's look at different ways of pose tagging. So first one is rule-based tagging. You have it over here. And this is one of the earliest methods of pose tagging. This approach uses a dictionary, also called a lexicon, and it uses it to determine potential tags for each word. So when a word has multiple possible tags, rules-based taggers apply manually created rules to select the appropriate tagger. So, sorry, to the appropriate tag. So disambiguation, so separation of words in this method, can be achieved by examining the relations of the word with the words before and after it. For instance, if a word is preceded by an article, it is likely a noun. So this is how this is working. Now let's look at another technique. This is called stochastic pose tagging. Stochastic tagging here. The question that arises here is which model can be stochastic? Um, a model that includes frequency or probability can be they both can be stochastic, right? So there are a number of different approaches to this problem of part of speech tagging that can be referred to as stochastic taggers. So in this approach with stochastic taggers, how we separate words or disambiguate, you will see in the literature the word disambiguate, so I wanted to underline it here a couple of times. So the way it separates the words is based on the likelihood of a word appearing with a specific tag. So in essence, the tag that appears most frequently with a word in the training data is assigned to any ambiguous instance of that word. So whenever we don't know what tag to assign it, then if it's frequently associated with a word in the training data, then we assign it that tag. So a key drawback of this approach is that it can result in invalid sequences of tags. So here, this word frequency approach is not so reliable. Then we have the second one, which is tag sequence frequency. And this is another method of stochastic tagging. This is known as also as the n-gram approach. And in this technique, the taggers estimate the likelihood of a particular sequence of tags appearing. Now the name comes from the fact that the optimal tag for a word is determined by the probability of its occurring based on the previous n tags. So these are not the only ones, by the way. There are other methods like pose tagging with hidden Markov models, others with deep learning models. You will see more of those probably in the artificial intelligence course and in the machine learning course. And if you want to read more about it, I recommend this article. This is a review article about part of speech tagging with deep learning and machine learning approaches. It's very interesting, and I can post it on Moodle for for whoever is interested to read it. And if you remember, if we get back to this NLP processing pipeline, we had this name entity recognition, also called NER. The main goal of NER is to analyze both structured and unstructured data and to classify named entities into specific predefined groups. So these groups could be these named entities can be names, locations, companies, dates, monetary values, and so on. The list goes on. But this NER, in summary, does two things. First of all is named entity recognition, so detection. By that is identify a word or a group of words within a document. And named entity classification in which it assigns each identified entity to its respective predefined category. And now let's look at this example because this, I think, explains it quite easily. So, sorry, we have here, for instance, John Doe has been working for ABCD Incorporated as a senior engineer since 2010 in California. Then what we would like to have is this kind of a table, where it doesn't necessarily have to be a table, but it can be a dictionary, it can be anything else, but it's visually really easily understandable. And what we would like to have is that John is labeled as a person, ABCD Incorporated is labeled as an organization, 2010 is labeled as a date, and California is labeled as a geopolitical entity. And now let's look at different NER approaches. There are several of them. The first one is dictionary-based, and as the name says, it uses a dictionary with specific vocabulary, and then it uses basic string matching algorithms to determine if an entity appears in the text by comparing it with this dictionary that it has access to. So this approach is kind of rarely used these days because it requires, first of all, regular updates and then maintenance of the dictionary, which means a lot of manual work actually. Then the second approach is the rule-based method. And this employs a predefined set of rules for information extraction. And these rules are based on patterns and context. So the pattern-based rules focus on the morphological structures of the words, while the context-based rules take into account the surrounding words within the text that is provided. The third approach, this addresses many of the limitations found in the previous two approaches. So it is a statistical model essentially, as you can imagine by its name, machine learning based approach. And this creates essentially a feature-based representation of the observed data, and it allows it to recognize these existing entity names even if there are spelling variations, which is very interesting and very useful. And the machine learning approach consists of two phases. So in the first phase, it involves training the ML model on annotated documents. And in the second phase, it uses the train model to annotate raw documents. So this process resembles essentially a standard machine learning pipeline, more or less. And then we have the fourth approach, which is a hybrid approach, which can be a combination or of any of the approaches we mentioned up till this point. And then we can use NER in many domains, like for instance, healthcare and biomedicine. So here, NER is used to identify and categorize medical entities. And you can think of medical entities like diseases, symptoms, medications, anatomical terms, and then sources to extract this from our electronic health records, research papers, clinical notes, and so on. This supports information retrieval and clinical decision making, which can be really good for patients and for helping them cure faster and getting better results in general. And another domain is, for instance, finance and risk analysis. So here, named entity recognition extracts information from documents like news articles, for instance, financial reports, And it identifies entities like company names, stocks, currencies, different financial metrics. And then it can also conduct sentiment analysis, monitor market trends, evaluate maybe investment risks, and so on. And it's very useful because it can automate fraud detection and then all other kind of processes like that. Then it can be used in social media analytics, so it can identify entities like user mentions, hashtags, locations, products, and so on. So it can help businesses understand customer behavior, conduct market research, and just in general engage with the target audience of the company. And then it can be used in many use cases for information extraction and search and so on. And the last part of our lecture is about n-grams. We briefly mentioned them before. So an n-gram is essentially a sequence of n words. So this is, again, very self-explanatory name. A unigram is, for instance, here we have this example, right? This is a sentence. Unigrams are this is a and sentence. And then for the same sentence, we would have bigrams as this is a sentence. And then we can have trigrams, this is a sentence, and so on. These n-grams models are useful in many applications where sequences of words are relevant. Some of those are sentiment analysis, text classification, text generation, and so on. N-gram modeling is also one of the many techniques that we use to convert text from an unstructured format to a structured format. They help, for instance, n-grams to address the challenge of finding linguistic relationships and context in data. For example, by extracting sequences of adjacent items, adjacent words in a sentence, for instance, or characters, even characters, n-grams can help models to understand the association between elements and create a deeper context. What we can do here with n-grams essentially is assign a probability of an n-gram and get useful information in what way? So we can find out which n-grams can be grouped together to form entities. For instance, New York, this would be an entity. This is a bigram, right? And then by this, it can help predict the next word. So if you see new, probably in that context, the next word would be York. And another important thing is that it can also help to make spelling corrections. So for instance, if you have a sentence, today's match result. So if we have this match result, so the result of a match, of a football match, for instance, if the S in result is missing, so we would have REULT instead. Because we have this combination of match result, then this n-gram can infer if the word is resolved because it is associated with this match. This also has a lot of limitations, so it's not perfect like nothing is. One problem is dimensionality. So the number of potential combinations of words rises exponentially. So there is a high dimensional feature space. You remember we talked about high dimensionality a few lectures ago. How you can mitigate this is through feature selection, where you can keep only the most relevant n-grams. Then another limitation is contextual understanding. So n-grams are really, really good at identifying local language patterns, but often they miss the broader nuances. So, for instance, if you have uh, something like a trigram like not good enough, this might imply a negative sentiment on its own, right? So it's something that's not good, it's something negative. Um, but if we have a sentence that is something like, this product was not good enough, but the customer service here was excellent, then the overall sentiment of this is not that negative, it's a little bit more positive. So then these isolated n-grams, like not good enough, like that trigram I said, they can be misinterpreted easily. So to enhance context capture, we can utilize more sophisticated language models than this. Another limitation of n-grams is overfitting. So in smaller data sets, it might become overly specialized to the training data and perform poorly on the unsynced text. You will see in the machine learning course specifically about how to alleviate this issue. You can employ dropout, for instance. You can do a lot of other things, but you will study more of that there. And then there is the problem of inflexibility. So n-grams usually don't perform so well with languages that have variable word order or noisy text because they depend on fixed sequences. And in order to deal with this, you can use some more adaptable models like RNNs, like recurrent neural networks, also transformers, which are something that is very modern and everybody's looking into them. But last but not least, reasons to choose n-grams are interpretability. They're easily humanly readable because they represent word sequences, and it's easy to understand which phrases um, influence the classification decision. So this is really good. The local context, they can capture immediate word relationships and local context. Um, then if we have small data sets, they can perform better actually than complex techniques. And in general, they're quite good for small data sets. Even though we have this problem, like I said earlier, so we have to make sure that they're not overfitting. So we have to employ something like dropout or some other techniques. Thanks for listening and see you in the next video.